Hello, good day. My name is Victor. I'm your mathematics and your science teacher. Today we'll be doing circle theorems. We have about 9 theorems we're going to discuss, and then I'll start with theorem 1 now. Before I talk about theorem 1, there are some basics I will introduce that I want us to understand even before we go deep into each theorem. Firstly, I will talk about alternate angles. So there are sometimes maybe inside the circle, you will see there are some shapes inside the circle. Then you might talk about this alternate angle, this, that. Don't forget it's a circle theorem or it's a circle geometry. It means inside the circle you see different kind of shapes. Maybe like a triangle, maybe like a rectangle, maybe like a parallelogram inscribed inside the circle. And then we try to calculate the angles of each shape. Let's say for example this is a circle, and this is a circle. I have a triangle inscribed inside the circle, something like this. So the essence of this is to calculate the angle of the shape inside the inscribed inside the circle. So don't forget, and I also say that we will be talking about how to understand this angle. Take for instance now, if I have a trapezium inscribed inside this place, something like this, a trapezium or a triangle inscribed inside this place, I will have to name it. So let's say I call this place A, I make this place B, I make this place C, I make this place D. It doesn't mean that I can move A, B, C, D. I can also choose to be this one to be A, B, C, D. It just means that you must follow a regular pattern. Are you following me? You can't make this one A and then make this one B. It doesn't make sense. You can either go in this direction or you go in this direction. So if I want to go towards this direction, I'll make it A, the first edge A, I'll make this one B, I'll make this one C, and then I'll make this one D. But if I want to go like this, I'll make this one A, B, C, D. It doesn't matter. It's still the same thing. So the angle here is called angle ABC. ABC. You can see that it forms angle ABC, and there's always a sign here, something like this, on top of B, to show that I'm referring to angle B. So also, if I want to talk about angle A, I'll call it BAD. Then I'll put a sign to show that I'm referring to angle A. So you can see it, angle BAD. So this angle B, let's say it is X. So angle ABC is what? Is X degree. This angle BAD, let's say it's Y. Angle BAD is what? Is Y degree. Are you following me? So this is how to know which of the angles we are referring to. And then if I come here and I say angle D, that's angle what? ADC. ADC. So angle ADC is equal to my what? My angle D. So let's make this one something like K is equal to K degree and so on. So don't forget. And apart from saying angle A is equal to X degree, it's also the same as saying angle ABC. You put a sign here, something like a less than before a less than sign before the alphabet. So this means this angle is also on B, it's also the same thing. So it's either you see it like this or you see it like this. We are referring to the same thing, just to be aware, to make sure you get this. And then don't forget, anytime you have a four-sided shapes, something like this now, it's a trapezium. Inside the cycle, we call it a quadrilateral. So this is a quadrilateral. This is a cyclic quadrilateral, rather. A cyclic quadrilateral. And you can see how we get each angles. And then also remember that Z angles is also called alternate angles, which means the angle here and this angle here, they are equal. So this is Z angle, so we call it alternate angles. So we are going to discuss about line and angles. We will talk more about alternate angles and then corresponding angles. Why this one is also corresponding angles? This one is alternate angles, we call it Z angles. Why this one is corresponding angles, or we call it F angles. The angle here and this angle, they are the same. The angle here and this angle, they are what? They are the same. So this is or we can do it any angle in the shape. It means this inside and outside. So you can see, so this is corresponding angles. take a look at this x degree. I call it angle ABC. It's x degree. So it is not CBA. Although if I call it angle CBA and I put it like this, you see the same thing. The angle is CB on B. But most of the time they follow the alphabetical order. A comes before B. So you see that it is called angle ABC. ABC is x degree, not CBA. Although you still get the same angle, but you see it is always written as angle ABC in the alphabetical order. And if there's any other things that I would like to introduce before we proceed, I will introduce. So let's take a look at theorem 1. Okay, we are going to start with theorem now. Theorem 1. Theorem 1, first one, says that a line drawn from the center of the cycle to bisect a chord is at right angle to each other. So I'll write from the board, a line drawn from the center of the circle, drawn from the center of the circle, from the center of the circle to bisect a chord. To bisect a chord is at right angle, is at right angle to each other. Sometimes it is necessary for you to memorize this theorem so that it will aid, it will make it easy for you to solve questions. So a line drawn from the center of the circle. So you discover that the first thing they are talking about here is a line. And this line is drawn from the center of the circle. That means there is a line at the circle. So I'm going to draw a circle. And what I'm going to circle, we said the line is drawn from the center of the circle. Let's say this is the center of the circle. And then that line is now drawn from the center of the circle to bisect a chord. So that means the line is drawn from the center of the circle to bisect a chord. And then this is a chord. Now, please pay attention. Remember that if we have a circle like this, and this is the center of the circle, any line that passes through the center of the circle and divide the circle into two equal parts is called a diameter. And if a diameter divide the circle, it divides that circle into semicircle. So this is semicircle, and y this also is semicircle again. Meanwhile, if now imagine that this is a circle, and we have a line that divides the circle into two parts, but now not two equal parts, into two parts, and does not pass through the center of the circle. So we have a line here. This line divides the circle into two parts, and it does not pass through the center of the circle, which is this place. So we call this line a chord. So a line that divides the circle into two parts but does not pass through the center of the circle is called a chord. While a line that divides the circle into two equal parts and divides the circle into two like this, the line that passes through the center of the circle to divide the circle into two equal parts is called a diameter. So remember we said a line drawn from the center of the circle. So the center of the circle, and a line is drawn from the center of the circle to bisect what? A chord. I'm very sure you already know a chord now. Any line that divides the circle not into two equal parts and does not pass through the center of the circle. So a line drawn from the center of the circle to bisect a chord is at right angle to each other. It means this place is 90 degrees and this place is 90 degrees. So that's everything about the theorem. Any line that comes from the center of the circle to bisect a chord is at right angle to each other. So I can join these places together so that I'll have a right angle triangle, and I can also join this place together so that I'll have a right angle triangle. So this is, please don't forget that it's not all the time you see something like this. The question might look like this. You might have a circle like this, and then the chord is up like this, and this is the center of the circle. I see something like this. So it means this and this are perpendicular to each other. And you might see something like this again. You might see a circle, and then in this circle you might see a chord, and then there's a line that comes from the center that bisects this chord. So it means this and this is 90, 90 degrees. This and this again is 90 degrees. Can you see how it changes depending on the rotation of the circle? So you see, I have something like this again, this, and then this is our chord. This is our chord. So let's take a look at example 1. The radius of a circle is 10 centimeters. The length of a chord of a circle is 60 centimeters. Calculate the distance of the chord from the center of the circle. So the first thing that we have is we have a circle. You have a circle. And then they are saying the radius of the circle. Now, don't forget that this is the center of the circle. Now, if I have the center of the circle, I said any line that divides the circle into 2 equal parts is what? A diameter. Don't forget that one. And they are not telling that the radius of a circle is 10 centimeters and the length of the chord is 60 centimeters. That means a chord does not pass through the center of the circle. I have something like this from here to here. From here to here, something like this. Let's say 16 centimeters. So from here to here is my chord. So I'll put it here, 16 centimeters. It's my chord, 16 centimeters. And then the radius of the circle is 10 centimeters. Don't forget that we said any line that comes from the center of the circle to bisect a chord is at right angle. So from here to here is 90 degrees. From here to here is what? 90 degrees. And then from here to here is what? 16 centimeters. And then the radius of the circle is 10 centimeters. If it's a diameter, this line that we have here is also a diameter. How do I do? It's divide the circle into 2 equal parts. It passes through the center, and it's the center of the circle. This is the center of this one diameter. This is another diameter. In fact, if I do like this, I will have another diameter. Just like what we have here. If this is the center of the circle, you will see that from here, I'll have a diameter. And if I join this line here, I'll have another diameter. And if I do it again like this, I'll have another diameter. And if I move this one from here to this end, I'll have another diameter. Just like the package of mind that a diameter is a line that passes through the center of the circle and divide the circle into 2 equal parts. So from here now we know that from here to here is a diameter, from here to here is a what? Diameter. And if you divide the diameter into 2, you are going to have a radius. So it means diameter divided by 2 will give you what? Will give you radius. So let's take a look at it again. So it means from here to here, we have this line coming from the center of the circle. And once it's coming from the center of the circle, we said from here to here is what? A diameter. If I divide it into 2, after from here to here is what? Radius. This is radius, this is radius. So if I move this one to like this is radius, this is radius. So let's continue. The question says the radius is what? Of a circle is 10 centimeters. So I can move and then show you what is really happening inside the circle. What we have is something like this. We have something like this. So we have, it is at right angle to each other, 1990. You see from here to here is what? 16 centimeters. And then from here to here is our radius, which is what? 10 centimeters. And then this is another radius, from here to here is what? 10 centimeters. So the question is, calculate the distance of the chord. This is the chord. Distance of the chord from the center of the circle, which we don't know. Let's make this one h, which you don't know, that's the height of the triangle. Distance from here, distance of the chord from the center of the circle. So that's what we're looking for here is what? Is h. After this, then I can divide this triangle into, you know this. We have two similar triangles here, one triangle, one triangle. So I can pick one out of it, and then so I cannot divide this one into 2. If I divide it into 2, I will just pick which is a similar triangle. This is a triangle. I can pick one side here. If I pick one side here, let's say I pick this side. From here to here is what? 10 centimeters. And then if from here to here is 60 centimeters, I'm picking a side. Don't forget that this line is perpendicular. It means from here to here is 90. From here to here is 90. And this line bisects the chord at equal distance, is equidistance. If from here to here is 16, if I divide it by 2, from here to here is what? 8. From here to here is what? 8. So that means if I'm taking one part of the triangle, if from here to here is 10 centimeters, then from here to here is what? 8 centimeters. And I'm asked to find the height, which is what? H. And then I can apply Pythagoras theorem and then what? Solve for h. What is Pythagoras theorem? We all know that one. The square of the hypotenuse square is equal to opposite square plus adjacent square. Opposite square plus adjacent square. What's the hypotenuse square? 10 square is equal to, what's the opposite square? So either of this side, either of opposite, let's say 8 square plus this one, which is 8 square. 10 square is 100 equal to 8 square plus 8 times 8 is 64. So my 8 square is equal to 100 minus 64. 100 minus 64 is going to give us 36. So our 8 square is equal to 36. Then 8 is equal to, once this square cross over equal to 1 moves to the other side, it becomes square root. So of 36. And our 8 is equal to square root of 36, 6 centimeter. So it means the distance of the curve from the center of the circle is 6 centimeter. Let's take a